24-volt alternating current circuit feeding a closed-circuit television camera is not considered a Class -1 circuit. Class -1 circuits are limited to 6 volts alternating current or 12 volts direct current. Since it is not a Class -1 circuit, there is no exception that allows it to run in the same conduit as the Coax. However, Article 725.136 of the National Electrical Code permits the sharing of conduit with power, communication, and signaling circuits, provided certain conditions are met. Firstly, the wires must be listed for use together in the same conduit. Secondly, the total load current of the power circuits does not exceed 50% of the conduit's ampacity. Thirdly, the power circuits and communication or signaling circuits must be separated by a barrier or divider. Yes, the aluminum bell boxes used to terminate the equipment at each camera drop must be bonded. According to Article 250.104(a)(1) of the National Electrical Code, all metallic enclosures must be grounded. The wires leaving the building must be in a raceway at least up to the first point of attachment unless other methods of protection are provided. Since the wires are in polyvinyl chloride conduit or flexible non-metallic conduit, they are considered protected. Protected cables must be continuously enclosed in raceways unless other methods of protection are provided. Since the wires are in polyvinyl chloride conduit or flexible non-metallic conduit, they are considered protected. Let's delve into the specifics of Class 1 circuits, conduit sharing, bell box grounding, and wiring protection according to the National Electrical Code. Understanding the nuances of these regulations is crucial for ensuring safer and compliant closed-circuit television installations. Firstly, we'll examine Class 1 circuits, focusing on the voltage limitations that define them. According to the NEC, Class 1 circuits operate at relatively low voltages, specifically 6 volts alternating current or 12 volts direct current. This limitation is designed to minimize the risk of electrical shock and fire hazards. The 24 volts alternating current circuit used to power the closed-circuit television cameras exceeds these limits, therefore it does not qualify as a Class 1 circuit. This distinction is important because it affects the allowable wiring methods and installation requirements. Next, let's explore the rules surrounding conduit sharing. The NEC generally restricts the mixing of power and communication circuits within the same conduit. However, Article 725.136 provides an exception that allows for the sharing of conduit under specific conditions. To leverage this exception, you must meet several criteria. The wires used for both power and communication circuits must be listed for use together in the same conduit. This listing ensures that the wires are compatible and that their insulation can withstand the combined electrical and thermal stresses. The total load current of the power circuits in the conduit must not exceed 50% of the conduit's ampacity. This requirement prevents overheating and potential damage to the wires or conduit. A barrier or divider must physically separate the power circuits from the communication or signaling circuits within the conduit. This separation minimizes the risk of electrical interference and ensures the integrity of the communication signals. Moving on to bell box grounding, the NEC mandates that all metallic enclosures, including aluminum bell boxes, must be grounded. Article 250.104(a)(1) specifically addresses this requirement. Grounding provides a low impedance path for fault currents, which helps to protect personnel and equipment from electrical shock. The grounding conductor should be properly sized and connected to the bell box using approved methods such as a grounding screw or lug. Finally, let's consider the protection requirements for wires leaving the building. The NEC requires that these wires be protected from physical damage and environmental factors. One way to achieve this protection is by enclosing the wires in a raceway, such as polyvinyl chloride conduit or flexible non-metallic conduit, up to the first point of attachment. These conduits provide a durable barrier against mechanical damage, moisture, and ultraviolet radiation. If other methods of protection are used, they must provide equivalent protection to a raceway. For example, you could use a cable assembly that is specifically designed for outdoor use and that has a rugged jacket that can withstand the elements. The key takeaway is that the wires must be adequately protected to ensure their long-term reliability and safety. Now let's elaborate on each of these points with more technical detail. Regarding Class 1 circuits, it is important to understand the different types of Class 1 circuits and their specific requirements. The NEC defines two main types of Class 1 circuits: Class 1 power limited circuits and Class 1 remote control and signaling circuits. Class 1 power limited circuits are subject to additional restrictions on voltage and current, as outlined in Article 725.41. These restrictions are designed to further limit the risk of electrical shock and fire hazards. Class 1 remote control and signaling circuits are used for applications such as controlling motors, relays, and other equipment. These circuits are typically wired using Class 1 cables, which are specifically designed for this purpose. When working with Class 1 circuits, it is essential to follow all applicable NEC requirements to ensure a safe and compliant installation. When it comes to conduit shearing, it is crucial to carefully consider the ampacity of the conduit and the load current of the power circuits. The ampacity of the conduit is the maximum amount of current that the conduit can safely carry without overheating. This information is typically found in the conduit's listing or manufacturer's specifications. The load current of the power circuits is the total amount of current that is flowing through the wires in the conduit. To ensure that the load current does not exceed 50% of the conduit's ampacity, you may need to use a larger size conduit or reduce the number of power circuits in the conduit. In addition to the ampacity requirements, it is also important to ensure that the wires are properly derated for the ambient temperature and the number of conductors in the conduit. Derating is the process of reducing the allowable ampacity of a wire to account for these factors. The NEC provides tables that can be used to determine the appropriate derating factors. When grounding metallic enclosures, it is important to use the correct size grounding conductor. The size of the grounding conductor is determined by the size of the circuit conductors, as specified in Article 250.122 of the NEC. The grounding conductor should be connected to the bell box using a grounding screw or lug that is specifically designed for this purpose. The grounding connection should be clean and tight to ensure a good electrical connection. In addition to grounding the bell boxes, it is also important to ground the equipment that is installed in the bell boxes. This can be accomplished by connecting the equipment to the grounding conductor in the bell box. When protecting wires leaving the building, it is important to choose a raceway that is appropriate for the environment. Polyvinyl chloride conduit is a good choice for outdoor applications because it is resistant to moisture and ultraviolet radiation. Flexible non-metallic conduit is a good choice for indoor applications because it is easy to install and can be bent around corners. If you are using a cable assembly instead of a raceway, make sure that the cable is listed for outdoor use and that it has a rugged jacket that can withstand the elements. In summary, to ensure a safe and compliant closed-circuit television installation, it is essential to understand and follow all applicable NEC requirements. This includes understanding the voltage limitations of Class 1 circuits, the rules surrounding conduit shearing, the requirements for grounding metallic enclosures, and the protection requirements for wires leaving the building. By carefully considering these factors, you can create a closed-circuit television system that is both reliable and safe. Remember that electrical codes are constantly evolving, so it is important to stay up to date with the latest requirements. Consult the most recent edition of the National Electrical Code and seek guidance from a qualified electrical inspector or engineer if you have any questions. Additionally, always prioritize safety when working with electricity. To energize circuits before working on them, use appropriate personal protective equipment, and follow safe work practices. By taking these precautions, you can minimize the risk of electrical shock and other hazards. The National Electrical Code is a comprehensive set of standards for electrical installations. It is updated every 3 years to reflect new technologies and best practices. Staying informed about the latest code changes is essential for electrical professionals and anyone working with electrical systems. In addition to the specific articles mentioned earlier, there are other sections of the NEC that are relevant to closed-circuit television installations. For example, Article 725 covers Class 2 and Class 3 remote control, signaling, and power-limited circuits. These circuits are often used for low-voltage power supplies and control signals and closed-circuit television systems. Article 820 covers community antenna television and radio distribution systems. This article provides requirements for the installation of coaxial cables and other components used in closed-circuit television systems. Article 300 covers general wiring methods. This article provides requirements for the installation of all types of wiring, including conductors, cables, and raceways. By familiarizing yourself with these and other relevant sections of the NEC, you can ensure that your closed-circuit television installations are safe, compliant, and reliable. Remember to always consult the most recent edition of the NEC and seek guidance from a qualified electrical professional if you have any questions or concerns. Safe electrical practices are paramount. Always double-check your work and never take shortcuts that could compromise safety. Electricity is a powerful force, and it should be treated with respect.